Okay, welcome to our latest video. In this video, we're going to be talking about the properties of a parallelogram. Going to be very important because these 5 properties that you see listed here, they're going to be the basis for a lot of what we talk about next class and the class after that. Pictured here, you see a parallelogram. Should obviously be familiar to most of you. You can you've seen this shape before. You've worked with it before. So we're going to discuss in detail some of the properties. The first thing I'm going to do is I'm going to give these vertices some names. I'll just call them A, B, C, D, and I will call the intersection here E. Notice how I labeled in order A, B, C, D, and I've also drawn with dashed lines the diagonals of this parallelogram. So let's discuss all the properties, some of which you probably already know already. First one, we'll stay with the most obvious ones, and we're going to talk about these opposite sides right here. Okay, the opposite sides, and then you have the other set of opposite sides at BC and AD. There's 2 things going on there. First, we're going to say that both sets of opposite sides are congruent. Now, we obviously can see that AB is not congruent to BC, but AB and CD are absolutely congruent, so we're going to mark them congruent. We also said that both sets, so the top and bottom, BC and AD, are congruent as well. Also with those opposite sides, not only are they congruent, but they are parallel. Notice AB and CD, these 2 opposite sides right here. Oops. These 2 opposite sides right here. Not only are they congruent, but they are parallel as well. We marked that with a little arrow. You should recognize that from class. And the top and bottom, BC and AD, are also parallel. So we're just going to say, and I'm going to use these little marks here, to say both sets of opposite sides are parallel. All right, 2 main properties of the parallelogram, very, very basic. The next thing we're going to talk about are the opposite angles. All right, and we'll take a look at, say, angle A right here and angle C right there. Those 2 angles, you should know, are congruent. So we're going to jot that down. So we're going to say both sets of opposite angles are congruent. So not only are A and C congruent, but B is going to be congruent to D. Next thing about the angles we'll also discuss is the angles that are next to each other. So yes, let's take a look at angle A and angle B. All right, those 2 angles are next to each other. Now obviously they're not congruent, but they do have a relationship. They are supplementary, so they're going to add up to 180 degrees. So we're going to jot down that adjacent. You may recognize that word adjacent meaning next to. Another word we would use is consecutive angles are supplementary. And again, everybody should remember that supplementary means adding up to 180. The last and final property that we're going to put down here is a really, really important one. We are going to say, we're going to talk about these diagonals. Okay. Now the diagonals, take a look at AC. Let me get a different color here. Take a look at AC, which is right here, and we take a BD. Now, just by looking at it, you probably can notice that they're not the same length, and they aren't. They're very different. One of them is longer than the other. In fact, it looks like AC is longer than BD. However, there is something very special that happens, and they do cut each other in half. So, for example, let's take a look at AC, this long diagonal right here. Let's say that that diagonal was 20 centimeters long. Well, then it got broken up into 10 and 10. Let's say this the shorter diagonal, BD, let's call it 12 centimeters long, which means it gets cut in half at 6 and 6. Again, that's what the word bisects means. So they are absolutely not equal, but they do bisect each other. And that's very, very important. Bisect each other. So they are cutting each other in half. These 5 properties, very, very important. The next thing we're going to take a look at is how we can apply these properties into some algebraic problems. Okay, so we got 4 problems here, or we're going to use the properties, those 5 properties that we just talked about. We're going to use most of them here. So if we take a look at this problem here, it says the opposite angles of a parallelogram, and it gives us these algebraic expressions for the measures of the opposite angles. So the key here is to understand the relationship. You see this term opposite angles of a parallelogram. They're talking about these angles right here, the ones opposite each other. And we just talked about that they were equal to each other. So it is as simple, or the algebra is as simple as taking the two angles, 3x minus 20, and setting it equal to x plus 15. We know the opposite angles are equal, and we know that the algebra, we just set up the algebraic equation of setting these two expressions equal to each other. If I solve for x, you should be able to get 2x equaling 35 and x equal to 17.5. All right, if we take a look down at number 2, we're talking about a parallelogram. It gives us an expression for angle B and angle A. It says that angle B exceeds angle A by 50. Well, exceeds is addition. So if angle A is x, that means that angle B would be x plus 50. So now that we got the expressions down, what's the relationship? Well, these aren't opposite. These are next to each other, or consecutive or adjacent angles. We learned that consecutive or adjacent angles are supplementary. So we can take x and the x plus 50 and equal it to 180 degrees. From there, you should be getting 2x equaling to 130 and x equal to 65. It says here that we want to find each angle, which means x plus 50, or angle B, would have to be 115 degrees. So we have our answers right there. So far we've used opposite angles and adjacent angles in questions 1 and 2. In question 3, if we take a quick read, it's talking about diagonals, AC and BD. So if you notice, I set myself up a little parallelogram, labeled it A, B, C, D, labeled the intersection in the middle E. So now I have BE right here, and I have DE right here. Let me put DE in blue, actually. Let's put that right there. So I got BE in red, I got DE in blue. It's telling me that BE is giving me the expression of 4x minus 12, and then it's telling me that DE is 2x plus 8. Well, the question is, what's the relationship between these two pieces? And if you take a look at that fifth property, we talked about how the diagonals bisect each other, or in other words, they're getting cut in half. So these two pieces must be equal to each other. So we can take 2x plus 8, and we can set it equal to 4x minus 12. And we can solve for x using that equation. From there, we should get 2x is equal to 20 and x equal to 10. All right. So again, that using the fifth property, diagonals bisecting each other. If we take a look at the fourth and final problem, we're looking for angles here. We're looking for, we know that we have a parallelogram. We've been given this one single diagonal, and we're being asked to find angle 1, 2, and 3. Now here's the good thing. Well, we're obviously going to be using concepts of parallelograms, but we can use any concept we want, and there's multiple ways to find these angles. Let's start with angle 1. If you notice here, I do have two parallel lines. I know that they're parallel because it is a parallelogram. This is acting as my transversal, so you should notice the relationship between angle 1 and that 30 degrees, and they are alternate interior angles. So we can say that angle 1 is equal to 30 because it is an alternate interior angle. Now again, why is it alternate interior angle? Because alternate interiors come from parallel lines. Well, do we have parallel lines? Yes, we do, because of the fact that it's a parallelogram. Take a look at angle 2 now. Some of you may notice that this is a triangle, and I know two angles of that triangle, which means the third one, angle 2 here, these three have to add up to 180 degrees. So by doing a little bit of math with 180 degrees, I should be able to find that angle 2 should be 28 degrees because angles of a triangle add to 180. All right. Again, notice how I'm providing the reasons too. Finally, we look at angle 3, and some of you might have been able to see this right away, but because I have a parallelogram here, which was told to me in the problem, I have a set of opposite angles right there. So I know that angle 3 has to equal 122 degrees because the opposite angles of a parallelogram are congruent. So not only did I find each angle, but I also provided a reason why each angle was what it was. All right, and there you go. There's your properties of parallelogram video. And then when we get in class, we'll take this a little bit further. All right.